haven't ever heard of like the idea of a set, so the third part of the assignment is to take your dynamic array implementation and use that as the basis for a string set. And a string set should basically act like an array, except that it only holds one copy of any duplicate value. So you can't put in two Davids in there. So that's what a set means. It only has single values, no replicated values. And there's operations that you can do on sets. So you take the intersection of two sets. The thing that you return from that is the part that's common to both of them. Some of you have seen this Venn diagram notation before, where this is one set, this is another set, and the intersection is the part that overlaps both, and the union is everything that's in both sets. Now, if there's a David over here and a David over here, are there going to be two Davids in the resulting set? No, it's a set, right? So there's only one David. So it has all the values in the sets, but no duplicates still. So you have to do a toString, and we're doing a little curly brace for a string set. And so if you print out your string set, it's going to be some curly brace looking like array kind of thing. So here, if I have a string set that has an A and a B in it, and I try to do the union with A and C, what's the resulting set going to be for that? So union is one of everything in each of those sets, right? So what do we have? Someone raise your hand and tell me. What do we got?
A, B, and C.
A, B, C. So you look at the first set. The first set has A and B. We need each of those. Then you go to the second set, and it has an A. Already have an A, so we don't need to duplicate it. And it has a C. That's new. So we add that in there. And the set that comes out of that method, it returns a value. It's a new set. It doesn't change this set. It doesn't change this set. If it creates a new set and returns it, that should be ABC, right? And the intersection one, what's the intersection of these two? Yep.
A and Z.
A and Z. So you go through, the way I do is look at the first one. So actually, here's the tricky part. You look at the first one and say, okay, I have an A here, and an A here. It's in both of them, so that's what we need for the intersection. And then you go B. Is there a B in the second one? There's not, so don't include it. Z. Is there a Z in the second one? Yes, there is, so we include it. So again, you can work it out on paper, and then you can translate that to an algorithm. Now actually, going back to the first one, the approach for that would be, okay, go to the first set and get your A, get your B, and I don't know, let's see, I'm trying to think, there's some place where people kind of falter and they don't go the opposite direction. Like you gotta then go to this, you pull everything out of here, but you have to pull everything out of here as well, right? You gotta use both sets. So these are just for loop kind of things in the code, just checking. And not too hard, but anyway, you have to know what it means in order to implement it. If you don't know what it is, then you can't implement it. That's the usual first step we always have, right? Do you understand the problem? Do you know what the terms are? All that kind of stuff. So make sure you kind of refresh your memory on sets a little bit, get in that mindset, and then the code will hopefully flow pretty easily. Okay? So I'm going to give some unit tests to help you decide whether you're correct or not, and think about sets. Anything else? I had a stray line in there about testing string set. I deleted it from the assignment. So if you saw that and were confused, it's gone. Don't worry about it. Anything else? Yeah.
How do I know if dynamic array 2 is working properly?
How do you know if dynamic array 2 is working properly? Well, does it do what the instructions say? No, but I'm also going to provide some JUnit tests tomorrow that should give you a basic idea of whether it's correct. Also, it should run on the speed test. If you run the speed test, it shouldn't blow up, right?
Yes, but for all I know, it could just be like doing something wrong.
Yeah, I know. It could be really slow or something like that, right?
Yeah.
Some of it's hard to test. Like again, this idea of make sure you're not copying stuff you don't need to copy. It's hard to test that in some ways because it just means you run a little slower. And the speed stuff's already it's not that precise to begin with. So you gotta look at stuff kind of just double check your understanding a little bit. Look at careful. Yeah?
I already wrote my own JUnit test and tested the method. Should I delete that code, copy what's already in this, and re-upload it, or should I just leave it alone?
We're not gonna try to run, we'll probably write yours anyway, so it's okay to be part of a zip file if you have your own tests. Someone asked about main as well, like if, you should write, you definitely should test it some way, right? You don't have to just wait for me to provide something, so you should provide, make a main function or main method that creates a dynamic array too. Can you add items to it? Can you insert them, that kind of stuff, and you can look at the results and decide whether it's doing something fairly correct. Whether it's precisely correct is harder to tell, but you can write your own main method, and that's good. You don't have to delete it before you turn it in as well. You also just won't run it. So make sure you're, don't write about it. Don't never ever write a bunch of code without exercising it a little bit, right? You gotta make sure it does something, because you're gonna be building each step. You're building on that stuff you've written, and so if you don't test the base, the foundation, you get a very shaky structure, and it's going to be hard to make it work. Anything else about the assignment, though? Yeah.
What do you want from the report?
What do I want on the report? I wanted some different size tests for the speed test, basically, right? And some kind of graph showing that stuff. And then you should talk using nice words. What's going on? Nothing out of control. Right? It doesn't have to be some huge thing, but again, make it look. Every once in a while, we get someone who scans some badly handwritten piece of paper, and that's not professional, right? Or it gives me a text file with some dots meaning a graph or something like that. Okay. Anything else? How about sets? A little comic. 2 sets. Computer problems that make people say, maybe it has a virus. And another set, computer problems caused by a virus. And what do you notice about these sets? They don't overlap, right? So everyone freaks out. Maybe it has a virus. Actually, I think one time I had a virus on my Mac, and it's like I knew I had a virus. It was pretty clear. Stuff popping up all over the place. You guys know this with the modern virus now? Like the current thing is not just putting annoying pop-up ads on there, but turning your machine into a Bitcoin miner. So like these viruses infect 1 million machines, and all of a sudden your machines are all mining Bitcoins for somebody, and so they're making their money by doing that. So anyway, if you just notice your machines are running hot for no particular reason, maybe you're mining Bitcoins and not getting the value out of that. All right. I think I've had this slide in like 4 or 5 lectures and I've never managed to get to it, so maybe you've seen it already. But when we talk about for loops, loops are a big area for mistakes. I mean, if you look at code, especially beginning code, it's like if statements are a huge source of errors, and then for loops are like the other big source of errors. And so people have been trying to figure out, and while loops are like even worse than for loops in terms of places to make mistakes, because it's harder to get all the parts right. So people have been inventing other kinds of loops trying to make it simpler. And basically this form is what we call a for each loop, and you give it an array, and this loop goes through that array one item at a time and sticks the value of the element in here. Okay, so let's just write some code for that. Code. All right, so I'm gonna let's make an array. Vowels, and I'm gonna initialize it 1, 2, 3. I gotta tell you, man, this daylight savings is killing me right now. I don't know, my eyeballs hurt. I'm thinking through sludge right now. I'm like, what do we need here? An array. Okay, here we go. So, I think I scheduled a midterm once on like daylight savings. That was a terrible. Okay, so let's just elements, and this is just vowels. So this is very terse syntax. It's hard to, until you get used to it, it looks kind of weird, right? And I can print out element, and if I run this, it's got a little bigger. Okay, so we get 1, 2, 3. So I have a 1, 2, 3 in an array. We're going to iterate over those 1, 2, 3 values, one at a time. 1 goes into element, we print it out. 2 goes into element, we print it out. 3 goes into element, we print it out. All right, so what's nice about this structure compared to like a while loop or a normal for loop? What's an advantage of using this, do you think? Yeah.
We don't have the index up.
So we don't have to have an index, but what's also good about that?
We don't have to define how long to go, so if we accidentally put less than and equal to. Or
Yeah, we never go off the end, right? It goes over every element in the array, whether it's size 10 or size 20 or whatever it is, and it doesn't make a mistake. Like it doesn't go starting at 1 instead of 0, and it doesn't go less than or equal to length. It just goes over the correct elements. Now, a downside of this is that element, in this case, is a copy of the value of the array. So if I try to like change element, and then let's say I did all this again. So actually, let's get rid of this set here. So I have a 1, 2, 3. I'm going to go through the elements of the array and add 1 to the element, and then I'm going to print out the elements. And when I run it, I get 1, 2, 3. That's because this element here is not a reference into the values of the array. It's a copy, it's its own variable. And so I'm changing the value of element here, but it's not changing the value of the element inside the array. Okay, do you see the difference there? Like this one is just one gets copied into element. We're not like magically referencing into the array here. So you can't really use this form of the loop to make modifications to the elements of the array, just to examine it. Yeah.
How would you extract a certain index, number of the index in the array?
So also, let's say we were also like using this to find the location of the smallest value. We can't really do it. We can give us the smallest value, but we can't get the index of the smallest value. So this doesn't have it. I'm a little nervous, like Python lets you do like both at the same time. And there's, there's other languages that kind of do this, and I'm like, does Java have this? I think it doesn't, but I need to go back and double check. Okay, so this is a very nice form where you just want to work through everything and do some easy print out or assign it to some other array kind of thing. But we're declaring our variable to hold each element value one at a time, and then we're giving the array over here. All right, so kind of weird form, but it's concise, doesn't make mistakes, has some benefits that way. All right, so we'll see this form more and more. Now, I wanted to just refresh our minds about primitives, because again, we're moving into objects more seriously, but primitives have their own behavior. They hold values, and when we use them as a parameter, an argument to a method, then that value gets passed to it. And let's just kind of look at that one more time, what's going on here. So if I have a static method, in other words, one that doesn't depend on any, we'll talk more about what static means, but we don't use any instance variables in a static method. Because we don't call it with an object, it's just by itself here. So thinking back to what static methods do, we give a name, we pass in a value, we return something. And if I created a primitive number here, in memory, you can kind of think of that again as a value in memory, and that variable is kind of closely associated with that location in memory, right? It's like that num is that spot in memory, not a reference to it. And again, this is going to be part of the stack over here that we're going to grow as we declare more variables. Then when I call a method, that value in num1 gets sent to this primitive parameter number, and number is initialized with that value 1, so number appears on our stack. And we do some work. This expression evaluates to 2. When you have a return value, that actually gets stored on the stack kind of temporarily. So this is not necessarily a val, but it's return value. That method call down here evaluates to that return value. So this return value gets copied, and you can kind of think of again as that expression becoming a value, and now it gets assigned to to none. Okay, so that's sort of the life cycle of a primitive, right? They appear in the stack, values get passed to methods, return values get passed back, and expressions get evaluated to some actual value, and then we can assign them to things, do other things. All right, so I think that's an important kind of mental model. Keep it, that's what's happening, and if you're debugging code, that's the kind of thought process you should be going through with these things. And if you don't have the right model, it makes it very hard to debug code. Things happen like magic somehow, right? And again, this is not a magic box. It's just that your mental model is off somehow and what's happening. You need to get locked in on the correct model to think this through properly. Now, we've been talking about objects a little more. So variables hold a value. Variables hold a reference to an object that contains the value. And so again, we have, we draw these various pictures where we might have val references some object, and the object over here and has a bunch of stuff inside it that whatever the object holds, and that's sort of the way you think about objects and variables that reference objects. Primitives don't have any methods of their own. They don't belong to a class in some sense, and so they don't have dot something on the end of them that means something. Whereas if you have an object, often there's some sort of useful method associated with that object, and we can ask the object certain computations. So if I have my object that's of some type, maybe we can call a do something method on it, and it looks inside its values and does something based on those. If you go to calling a method, again, it's a copy of the value of the variable for primitives, and it's a copy of the reference for objects. And this is the thing that makes us allowed, we can change the internal state of objects where they're inside a method, because we're not copying the entire object, we're just pointing to the same object on the heap. And so if you say, my object.x now equals some other value, that persists beyond the method call. And the other thing is that there's sort of a strange special case null for object variables, that they don't have to actually reference any particular object. They can just say, I don't reference anything yet, and that's a valid state for those things. So again, these are kind of little distinctions, and you have to kind of think about them when you're working with code, which side of this you're on. Am I passing a value? Am I passing a copy of the reference? Those kind of things. And that helps everything, again, make sense when you're working through code. All right, questions on this part? So this is sort of review, but maybe not, concise little table here. Help think about things. All right, so let's do a search loop with primitives, just as a review. So I'm going to, already tabbed over, do a public static int search for key on an int array, and looking for an int key. So this is, again, a basic kind of operation. We're going to pass in an array of values, and we're going to just go through all of them and see if the thing I'm looking for is in there, right? So I'm going to use our new magic for each loop on the array, and I'm going to check to see if element is equal to key, and if it is, I'm going to return the key. So basically say I found this value. It's kind of weird if we pass key in, I know, but it at least double checks that we're working on the same kind of thing. I'm looking for this value. I found this value. It's not the index here, right? It's the actual value. So that's cool. What happens if I don't find the key? What should I do? I got to return something. In fact, it's complaining to me still. Like, this method must return a result of type int, and I'm returning a value of type int here, but it doesn't have to hit this line, right? It might not execute it. The Java compiler is smart enough to realize this thing inside an if might not execute, and then nothing is going to return. So what can I return if I don't find it? So we can try something like this. What's the problem with this? I might have -1 in the array, right? It might be what I'm looking for even. And so I'm basically saying I can find everything except for -1s in arrays now. And I'm kind of stuck at this point. If I was returning an index, then I can kind of avoid this because there is no -1 index, and that's a special case. And so if I had not done my fancy new for each loop and instead done index equals 0, index less than array length, then I could return the location of the item that I find, which is probably a better choice anyway. And then I could return -1 as a special case, but if I'm returning a value, -1 is not a special case. And so that's sort of a bad thing here. Like we're sort of used to returning -1 as some sort of special case, but there's nothing weird about -1 in the world. It's just that we've sort of decided it's a little bit weird, and it's going to catch us at some point when, I have some other data in here. So this is not really a fully correct kind of thing. Now, in some ways, this is a fault of primitives. The primitives have a set of values they hold, and none of them are special. They're all good. And I want a special value. So one way to fix this is Java has a bunch of classes. They're kind of funny. Not really funny, haha, but strange, I guess. And they're called wrapper classes. And so for each primitive type, there's an equivalent wrapper class that holds those values, but is an object. So all the rules that apply to objects apply to the wrapper classes. So for Boolean, there's a capital B Boolean. For byte, there's a capital B byte. For float, there's a capital F float. There's sort of a pattern here. Unfortunately, it's not quite a pattern because I was going to say, look, you just turn the first letter into a capital letter and it works. And then all of a sudden you get to char and character and int and integer. So the pattern really isn't there. I was all excited for a second. But, so these wrapper classes are things that they're very simple. They just have inside an instance variable that's of the corresponding primitive type. And you can pass them to make arrays of them, and you can make, pass them to methods and so on. Yeah.
It's a little off topic, but what can you store in the byte variable? Because I've seen that around, but I don't know.
Byte is basically a very small integer that only holds values from 0 to 255.
So binary.
But it's not, yeah, I mean, so it's sort of, it's a memory level kind of thing. And you'll see more about that at some point in your life. So let's look at an example integer class. So if I wanted to make one of these things, I declare an integer type and my value. And anytime you make an object, what do you have to do? Renew it, right? So it's a new integer. And I'm going to construct that with a value 5 inside it. So that holds a value 5. And I can do things like ask what value is in there. Int in my val equals my val int value. So I use a method to access the value stored in there. Right? So I can put a value in, and I can get a value out. Which is not like the most exciting thing in the world. And if I print that out, I can print out int in my val, and hopefully we'll see a 5 appear at the bottom of all our stuff, so the 5 comes out. All right, so I've made one of these things, and I can get the value out. Now I could use this in an array as well. So if I say integer array, what was the other one called? Vals. I don't know. Vals too. Equals. So what am I making here? What am I declaring? What kind of thing is this? It's an array. That's the important thing, right? Don't get fooled by the big integer here. We almost don't care what that is. We just care that we're making an array. So I'm going to make a new integer of size 5. And what is this array going to look like?
Same as an int array?
So we have vals2. It's going to reference array that has 5 things in it. And objects are automatically initialized. What is this initialized to? A bunch of nulls, which I'm going to write those. All right. So be careful. Anytime we're making an array of objects, that array is initialized to null values. And we have to fill it with actual other objects. So at some point I need to do a new integer and make this reference that integer in memory somewhere. So let's make one of those for int I equals 0, I less than vals 2 dot length, I plus plus, and I'm going to say that vals 2 at location I equals a new integer with, let's put like I times 2 in there or something like that, get some actual values. And now if I were to do a system out on the arrays to string on vals 2, let's see what's in there. All right, so first time through I is 0, 0 times 2 is still 0. Next time through I is 1, 2 times 1 is 2, so it puts all these values in there, okay? So we managed to fill it up, but we get sort of a little lazy with primitive arrays of like ints, because they automatically get set to 0 and you can use them right away. Again, arrays of objects, you have to actually populate with some objects.
Once you have that initialized, if you were to print out vals.i just without the array type, would it give us the location of memory, or would it actually do the integer?
So, okay, so vals 2 of 0, like that?
No, I. Or some, yeah, some.
It's
some
just one of
location.
them. Yeah, just picking one. I'm out of the loop at this point, right? So,
Vals 2.
oh, vals 2. I was like, 1. Yeah. Okay. So the reason we get this is because the integer object has its own toString method, and when you try to print it, it uses that toString method to get to it.
Automatically.
Yeah. So it actually makes it hard to see what's going on a little bit, right?
What if, so if we just did vals 2, then we just get the memory location?
Vals 2, that's an array, and arrays say what kind of thing they are, and they're what's called the hash code, which is roughly their where. All right, so let's rewrite our search loop here to maybe take advantage of being an object a little bit. So public static integer and search for integer key, and I'm going to take an integer array. It's like, can I say that any more annoyingly? integer key, and in here I'm still going to use our for each style loop for integer element on array, and I'm going to say if the element, I want to compare element to key. How do I compare it? I got to use dot equals. Objects, you got to compare I want to compare the values here, right? And make sure that I'm not, so equal means it's the same identity, the same objects in memory. Dot equals typically means that the values are the same. All right, now I want to compare values. So if it equals key, and I need some parentheses around there, then I'm going to return the key. And if I search them all and don't find it, what can I return now? I can return our special case. null here, right? I didn't find anything. So that's sort of nice in some ways. This is not the full value of these wrapper classes. We'll talk about that pretty soon. They're good for using in more complicated structure Java has. Once we move beyond sort of simpler ways, we'll need to use these wrapper classes for that kind of stuff. Now, these wrapper classes have some kind of weird behavior. Like, I find this to be a very strange concept in some ways. So let's look at this. So, integer class, search loop, initialize that. These wrapper classes, something called autoboxing and unboxing. And it makes, I don't like it, to be honest. I just don't really like it. But, so, if I say integer myInt equals 3, that's a weird thing because this is an int and this is an integer, right? But it lets us do this. Do what's called autoboxing. And really, when it sees something like this, it translates it internally into new integer 3. In other words, it automatically wraps this raw primitive in an object that allows us to assign it to myInt. Okay? And then unboxing goes the other way. So if I were to have myInt plus 3, that's weird again because this is an integer and this is an int. And mixing those two different types around a plus sign seems like an odd thing to do. But Java automatically says, oh, we need a value out of here. So use the myInt int value, get the value out of this thing, and add it to 3. So it allows us to kind of seamlessly mix in primitives and objects. And again, it's sort of because these wrapper classes don't have a lot of independent value. They're just sort of there to hold these primitives in a class, in an object. And so they want to kind of make it as easy to use as possible. Now this has some strange, and another thing is, that's important about these classes actually, is that like string, they're immutable. In other words, once you've declared it with a value, you can't change that value. In other words, there's no setter on these classes. There's a getter here, this int value, but there's no set int value, so I can't change the internal value to be something else. All right, so that's kind of weird as well, but basically, if you have something that is an object that holds a 3, then you want it to hold a 3 forever and not suddenly be a 5 inside there. And that's also a little bit of a consequence is that Java actually pre-makes a bunch of these values for you, like simple numbers. And so it knows that somewhere there's an int object that holds a 3, and every time you ask for one of those things, it uses this like same cached values. It's not making a bunch of new objects for you. But if that object that holds a 3 was suddenly hold a 5, then we'd have some problems basically because it thinks it's a 3.
So if you were to do like after you initialize it, then you myInt equals 5.
So that's a question. Can you do? Okay, so let's go look. So I can't change what's stored in an integer object, but
We can link it to a different.
I can do some other stuff. So, okay, a lot of stuff going on here. Let's make something here. Okay, so if I have an integer a equals 1, that's going to be auto-boxed to make a new integer object with a 1 inside it. And if I print out that a value plus a, we're going to expect to see a value 1. That's cool, right? And I can't change that 1, but so this seems sketchy, right? I'm not allowed to change the a value, but it's a 2. So what's going on here, right? I just said you can't change it, and I just change it. How rude of me. So let's work through what this means. All right, so we have some memory over here, and I said 1. And again, you should mentally think of this as a equals a new integer with a 1 stored in it. And so what that means for us is that we have an a value. It's a reference to an object. This part here makes a new integer object on the heap somewhere. That has a 1 in it. And a references that object. Okay? A is on the stack. A is a variable. This part that it references is on the heap. And there's a new integer 1. Then I go down and evaluate this expression here. And there's a lot going on here, right? So what does it say? It says a equals a plus 1. How do we evaluate this expression? Well, a equals a dot int value plus 1. What does this evaluate to? A 1, yes. So we get 1 plus 1. So now we can evaluate this right-hand side expression, and we get a equals 2. What happens to an integer when it sees this?
Autobox.
It autoboxes it. A equals new integer 2. All of a sudden, we need to evaluate this expression. What does this do? It makes a new integer object that has a 2 in it. It says assign this reference to a. So we're not changing this object. We didn't change what's inside it. We just reassign what a is referencing to a new integer object that has a 2 in it. All right, so the weird thing is you can't change these integer objects, but you can sure do a lot of things that act like you're changing them, but it's this really whole, this is not an easy process, right? It's going through and doing all these steps. Get the value out, evaluate the expression, make a new object, stick it back on there, right? So this is a lot more expensive than just adding 1 plus 1 and storing it in a primitive.
Is this essentially less efficient code?
It's a lot more going on. Yeah. Anytime you're making an object on the heap, it's a lot more expensive than just static.
So if you're programming for efficiency, it'd be recommended not to do this, really?
Well, to be honest, then there's all these layers. The compiler then makes decisions like, we never really treat this like an object. Let's just keep it in primitives. Like it may be turning it back to primitives for us and not really doing it. So it's really hard to tell. Like Java's really smart. It does a good job. So don't worry about it unless, if all of a sudden your self-driving cars not seeing pedestrians and in time, you should investigate what's slow in your code, but don't make life hard for yourself just because you feel like you're worried about performance until it's an issue. That's usually the rule of thumb that's important there. Okay, so this is the kind of thing that I find sort of mysterious. This integer a is immutable. I can re-reference something with it. And it essentially changes the value that it's holding, but I'm not changing any of the individual objects. Real good kind of test question, don't you think? Real kind of basic, check your understanding on things. Yeah. Okay, so questions about that though, while we're looking at this. Notice in order to understand this model, there's a bunch of parts, right? This stack stuff, I'm referencing things on the heap. If you're not getting that background model, you're going to really struggle with how this stuff really works. And so make sure somehow that you're able to take these kind of commands and kind of draw these kind of pictures and make sense out of it. Otherwise, if you're just working on the wrong understanding of stuff, again, you'll never see why why you're allowed to do a equals a plus 1, right? You have to get this background kind of stuff down pretty well. Okay, now. This whole thing seems kind of mysterious in a way. What is this integer class? It seems like a big, hard thing. But really, we can write something that's pretty close to that in just a second here. So we want a class that holds a value. So I'm going to make a class that has a private int that holds an int val. And I'm going to use a constructor on my integer that takes in an int val. And in there, I'm going to assign that parameter to my instance variable, int val. And I'm going to have a getter, int value, that returns int val. And again, that's really the same as this dot int val, right? That's the object value. And I want it to be, int. And we get in the habit of writing getters and then setters, but no, immutable, can't change, right? So we don't need a setter. And that's basically it. This class basically acts like the big integer class, except for all the sort of truly magic autoboxing and unboxing that is somehow the Java compiler does a bunch of stuff that we can't force Java to do that for us with this. But the integer class is basically just something that holds a value. The constructor takes in a value and assigns it, and when we want the value out, we use it like that. So don't think that, again, you see these things in Java and they seem like, I don't know, like the code for that must be some huge big pile of stuff somewhere that the Java developers were working on for 5 years to make it all work, and some intern threw out the integer class on a weekend, a day in the summer kind of thing, right? And it wasn't any big deal. So none of this stuff is beyond you at this point. You're all able to do these kinds of things and really write a language if you wanted to, almost, right? Not really yet, but. And we can use this just like the integer class. Let's just do that one little thing with that. So if I make my integer b equals new my integer with a 10 in it, and then I print out my int value and ask for b's int value, then we should get that 10. All right, so we basically made something that acts kind of like the integer class, wrapper class, but it doesn't have the cool boxing and unboxing that I don't like anyway, so I want to use mine because I like it better. All right, so that's basically it. Just want to introduce you to the concept of wrapper classes. We'll see more uses of these as we get into more complicated array types, but that's the basics here.